Hey everyone, welcome and thank you very much for attending my research presentation. Today I'm going to be discussing implementing blockchain-based internet voting systems to improve the integrity and availability of the US elections. So I know that's kind of a mouthful here. If you could just bear with me as we kind of unpack some of this, and we'll get into it later, but know that in short this means how you'll cast your vote in the future. Our agenda for today is going to begin with our introductions. This includes introducing blockchain technologies, a little bit about where it originated, into our current concerns with the US voting systems and elections. This will move into our hypothesis of how internet-based and blockchain-based e-voting systems will improve this. And then we'll start to take a look at some of the related works and real-world examples, which are actually pretty cool that you can see these being implemented in time and space to solve other problems. And we'll take some of those real-world examples and use it to build the blockchain as a solution for the US election and voting system. And then in conclusion, we'll kind of reiterate some of the points and begin to talk about future works. So, introduction to the blockchain. So, why do we see blockchain technologies popping up everywhere? It's almost, you can't go a week without hearing about a new tech startup that specializes in blockchain technology. And I think part of this is that it is the flavor of the week, it is the cool thing for now, but there is a lot of utility there that I don't want lost. So what is the blockchain? I'm going to take one of the most notable examples of blockchain technologies, Bitcoin, which is a cryptocurrency leveraging the blockchain, and take from Satoshi Nakamoto, the anonymous creator's original white paper. We'll take his version of what the blockchain is and what started a lot of the foundation of the current blockchain we know today. And if you look over at the image there, that's actually from his white paper. And it's going to explain that owners transferring their currency are going to sign a hash of the previous transaction and append the public key of the next transaction at the end of their coin. So essentially, what they have is they're taking and hashing information from the past, and they're including information from the next transaction, thus creating a chain. Additionally, on top of this, a timestamp server is going to be taking hashes of all blocks and timestamping them. So that's going to be putting a date of where the chain was at each location. And then additionally, each timestamp is going to be including a hash of the previous timestamp. So again, it just builds on itself to ensure that this is not able to be corrupted and that there is a living record distributed everywhere. So now this is an example listed from a cryptocurrency, but we can pretty much use blockchain technologies everywhere, and you'll kind of see that in the future with one of our voting tokens that we'll be using here. So introduction, integrity concerns. So one of the things we'll see, and a lot of this information I've sourced from the Brennan Center for Justice, has done a lot of works on essentially anomalies and voter fraud in the United States. And these are two particular papers that stuck out to me from 2015 and 2007. The first one was one of their papers from 2015, in where they mentioned US voting systems are severely outdated. So this was essentially noting that 43 states have voting machines that are over 10 years old, and then 14 of those states have voting machines that are over 15 years old. Now, I don't know if you've ever remembered what a 15-year-old computer looks like, but I showed an image on the side of the screen right here for you, just to remind you, this is what a 15-year-old computer looked like. So it's pretty needless to say that this is going to lead to a lot of vulnerabilities and equipment failure, having those old devices. Again, another thing is that they found in these reports are voting anomalies and fraud does occur. So now, the most notable case of this is in the 2004 Milwaukee, Wisconsin general elections. They had done a lot of research on this because it was a very controversial election, and they had found 7 substantiated cases of fraud, meaning a vote was invalid, but it was cast by someone who had said essentially this should be valid. So it was fraud. And then thousands of voting anomalies also occurred during the same election. So this includes 238 cases of uncounted absentee ballots, 600 uncounted votes due to an old machine error, and then 8 boxes of registered voter cards that were not logged and made people unable to vote. So if you notice, most of these errors were either human error or outdated equipment, and that had huge impacts on the integrity of the voting system. Now I'm going to introduce some of the availability concerns here. So how difficult is it to vote right now? When you want to go vote, you have to physically take yourself to a location, whether it's a polling center or wherever it is set up that you go vote. You have to drive yourself there. You take time out of the day. These difficulties, there's not really much data on if this stops someone from voting, but a lot of the time what we have to do is you'll have to take off work, you'll have to stop your responsibilities with your family, etc., whatever it is, and you have to go vote physically, which takes time and it takes effort. And my question here is, why aren't we leveraging these internet-based voting solutions yet? In a Pew Research Center dataset taken this year, which I've shown you on the right here as well, you can see that 70% of Americans have home internet access, which is broadband speeds or better. 15% of the population does not have broadband speeds, but they have mobile internet access available. And only 8% of the adult population in the US does not have any internet access personally available. So 92% of the population has that access. We should be leveraging voting solutions on the internet. So my hypothesis is that we begin implementing a blockchain-based internet voting system, and that they will increase the overall integrity and availability of elections in the US. We'll kind of start to see why I think this, judging on some of the use cases here and just the possibilities of what we can do with the blockchain. So related works, and I think this is one of my favorite pieces of the research that I completed, was just seeing some of the other people actually use this. And this case from decentralized e-voting systems based on smart contracts using blockchain technology, they validated a bunch of technical pieces that was really interesting to this research. And they essentially coded tokens. They coded a voting token, which was created using Solidity on Remix. And Remix is the compiler or the IDE, and then the token itself made in Solidity, which is essentially a similar syntax to JavaScript for anyone who is familiar. They went and deployed this to an Ethereum testnet. So they had actually deployed the token to a testnet that was visible to everybody who had access. They had integrated this with wallet decentralized applications like MetaMask, which they had used to control the flow of tokens, sending them back and forth and things like that. And they had also built a front-end application that integrated a smart contract, allowing them to vote on their system. So all of these things together just showed that it is feasibly possible and technically possible to do this. There were some downfalls to this, that it was done in a local environment. It was not put to the test of security audits or any sort of bad actors trying to get in. So I will say that this is just a great way to look at it technically. We don't know if their solution was scalable or secure. But this is a great start here. The next related work I'm going to go into even takes this a step farther. And this is a real-world application, or several real-world applications of blockchain-based e-voting systems that have occurred. And the first one here is by far my favorite example that I was able to find online about this. And that is Russia's Active Citizen application. So this started as an internet-based e-voting platform, and it's in 2018, I'm sure the number's more now, they had used it already to create 3,450 polls. These are relatively low-impact polls in terms of they will go and talk to a housing community and ask them how they feel about planting a new garden or something low-impact like that. And I'm not making that up. It's generally, that's about what they had it doing. But it is relatively low impact. And they had this software also externally audited, their application by PricewaterhouseCoopers, PwC. And they were moving in the right direction and ensuring a secure voting platform. Unfortunately, those audit results were not published, obviously due to reasons that you wouldn't want the vulnerabilities in someone's hands to exploit. But just the idea that this application was working in completely the right direction and how a voting system should start before it scales into high impact voting. So the next case I have here is Sierra Leone, the 2018 general elections. So this I'm going to call a blockchain assisted voting platform, which was helped out by the Swiss company Agora. The way that they had conducted this was blockchain assisted because initially they cast votes on paper and then they transferred these paper to a traditional database, so there had to be someone physically inputting them. And then also the databases in a certain district, it was their western district of Sierra Leone, were moved over to the blockchain for auditing. And now this is, again, blockchain assisted because there were so many places here to introduce vulnerabilities, whether it was the paper ballots initially, whether it was moving the ballots to the data centers to be implemented, or whether it was someone improperly putting the data into the system with inputs. There were so many places for either bad actors or negligent employees to have a negative impact on this election. So again, this kind of can be used as a what not to do if you are conducting a blockchain audit. Blockchain needs to be integrated as early as humanly possible, and security always needs to be a concern, and it shouldn't be used for auditing later. So with that said, with some of those solutions in mind and some of those good things we've talked about and the bad, we're going to move toward creating a solution. So obviously, we've already kind of mentioned it, very few blockchain-based internet e-voting platforms have been used in real-world applications. So the blockchain has many use cases, e-voting is included. So how would we go and implement this? So here is kind of how we go and begin to start implementing this, moving from a small scale to a larger scale and naturally incrementing it. So I think the first thing you have to do, we would have to go and select a use case that makes sense. So whatever case it is, you would need to go to a specific community, recommending starting on something like a city level. Again, back to the active citizen, they have implemented it for local polls and things like that. That is generally where you should start, at that smaller scale, just to test it out, and then go get buy-in from the local community and local governance officials to ensure that everyone is on board. And once you've gotten that approval and you know that the community is going to be on board with you, you can go ahead and start actually deploying some of these things. So the first thing you're going to have to do is deploy a private blockchain. Now, this is different than some of the other instances, such as that first test I mentioned that was local. They had used an Ethereum testnet. In this case, you should be taking an instance of an Ethereum blockchain and deploying it privately on your own nodes to ensure that you have control over any outages or exploits, security issues, because you don't want to be accountable for Ethereum, the network going down, or having eye congestion so you can't use your voting platform. Additionally, on top of the private blockchain, you'll have to go into designing and deploying a web application that has smart contract interaction. This is just extremely important because you need to make sure that whatever users are using, including Android, iPhone, or the web on their home computer, they should be able to access this securely and easily. So I think there's going to be a lot of pieces here, including UI and UX, just ensuring those are good and simplified for a good user experience and a secure one at that. So once you've deployed all of these things, you can go into internal testing and auditing. And depending on how the results are, if you're failing all of your security tests and you find out that this just isn't going to work, you can obviously go back to square one. Hopefully that's not the case. You've passed your test, and now you can begin with smaller scale, low impact implementations in the town or the county that you've decided to work with. And this will begin to validate just your use case and see if this actually works. So now, did this work? Do more trials need to be run? That's going to be our next question we ask on number 5 there. If more trials need to be run, then yes, we go back, don't worry about it, we go and we run more trials. Now we figure out if the town hall needs a new garden in the back, and we keep retesting on these low impact, low scale things. Once you finally reconsolidated enough and you feel that you're ready to scale, we move on to testing and scalability. The scalability and security testings at scale is probably one of the most problematic pieces of this whole thing. So you'll notice there on 7, as is the application and network scalable. If you find that it's not scalable and for whatever reason your network can't handle the congestion, you've improperly coded your token, you didn't produce enough to be able to redistribute between the masses of your goal, which is hundreds of thousands, if not millions of people voting on this, you have to go back to square one and kind of restart this all over again. Because if it's not scalable, it's never going to meet the end goal of getting to that national use. So that can either make or break you being scalable. If you figure out, okay, everything we have is scalable, then we're going to figure out, is this application secure? We conduct our code audits again, we conduct penetration testing, and we just make sure everything is good to go in terms of actually deploying this at a large scale. If we've passed that, and we're good to go, we begin some large scale trials. And again, this is going to start on whatever it is, a larger level, but it's still going to be lower impact, recommending starting with the polls or with low scale votes and things that don't really matter as much. Moving forward towards retesting and improving this, whether it's improving the user experience again, making it easier for more people to use, or even just retuning security on the applications and things like that. You just retest and constantly improve your product, and then eventually, after so many implementations of this on the large scale with a low impact, you can begin scaling this to high scale, high impact operations with a scaled product. Now, I kind of talk about this as if it's easy to do, and I think it's not an easy problem to solve, but I'm going to say it's completely feasible, which is something I've mentioned throughout this. But why has no one conducted a full implementation of this? And what I'm going to say is it's big and bold here. No one has conducted a full implementation of a blockchain-based e-voting system because the risk is very high. So obviously, I've taken this, I'll go back to the last slide here. I've taken these steps here to try to ensure that you're hitting the least risk possible as you start to scale it up. So this process is probably going to take place over years to ensure that that risk is mitigated to the most of what you can and still also try to innovate with this product. But what is really hurting is we're in this market now where everyone is being avoidant to this risk. Whereas like the Russian active citizen, I think they've started and they're not really avoiding it. They're trying to mitigate it and starting at a small scale. I think we've kind of avoided this in the US, and the availability and integrity of our systems are being compromised because of that. And we need to start accepting a little bit more risk and mitigating that along the way by using this scale up plan. Now, hopefully someone is going to come along in the future who changes that, and that kind of gets into more of the future works. So now again, in conclusion, a blockchain-based internet e-voting system is going to provide us with the following. It's increased security and auditability due to the blockchain technologies, and increased availability due to home and mobile internet usage. Now, again, it is feasible. I think with enough time and with a dedicated community, again, someone who's willing to test it with you, this could be done. But the biggest barrier to entry is accepting that risk that this might not work or that it might fail at first. And if we really want to innovate in this field, our future works are going to have to be based upon accepting this risk and moving forward to continue to research this domain. Here are my references. Got a bunch here if you're interested as well. You can please reach out to me. Again, Robert Jones from NYU. Thank you so much for watching, everybody. And I really hope that you have a great night. So have a good one, everybody.